Bonjour, this is Bruno LARVOL, and you are watching our weekly podcast, Building in Public. LARVOL CLIN is the name of the product. My guest today is one of our rockstar team member, Ankit Kalucha, who is going to talk with us about how we're using AI in LARVOL CLIN to extract sentiment from tweets, sentiments about clinical trials. Before that, a quick infomercial. So, Larvol is a oncology data intelligence company. We focus on oncology data, and Larvol CLIN, which is our flagship product. Think about it as a Wikipedia of cancer data. Not every type of cancer data, very specific type of cancer data, published clinical trial data. But there's a lot of it. It's very well structured, and Ankit, over the last couple of years, has been key in enriching that data with AI and LLM in particular. Ankit is both a pharmacist, an MBA, and is now completing his degree in machine learning and AI. Although the field moves so fast and you're so on top of it that maybe you could probably your teachers can probably learn something from you. I would bet. So, Ankit, welcome to the podcast.
Hi, thanks for having me, Bruno. Here, it's a great pleasure. Uh, I would like to discuss a particular use case that we have in CLIN. That's the sentiment analysis, as you mentioned. Let me share my screen for that.
And as you get ready to share your screen, I want to share a little anecdote myself, which is that for many years, I told people heuristics or AI cannot extract sentiment. It's too difficult. It's too context sensitive. And I was so wrong. I now say that human analysts, should not take extract sentiment because human analysts are not going to be consistent in the way they interpret the sentiment of a tweet or of other documents. And with an LLM, there's a level of consistency that is actually very, very valuable. The example I use is what I really hit me is that the work you did, the AI did not hesitate to say that a tweet that said no MRD, that was the tweet, no MRD, that's it. MRD stands for minimal residual disease, no MRD. And the AI had no problem saying it's a positive tweet. It's a positive tweet, despite the fact that it has a word no and the fact that MRD is not defined and doesn't have any context. It rightfully understood that this was a positive tweet. So AI won, right? That's it. So go ahead and explain maybe how you build that technology and the results.
So I'll take one of the examples that we have. We recently had Expo 2024, and we had some 1,100 tweets around this conferences. Uh, the the task that I had was for every abstract or the trial in that abstract, we wanted to first have the tweets in our system, and then how those tweets can be categorized to solve some business use case around that trial, whether the 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 DOLs are they negative around that trial, are they saying positive stuff, or it's neutral. And the biggest one is practice changing, which was very hard to find out because the distinguish between practice changing and positive is a critical, but I think the most useful one to be in track, to be on track for the pharma pipelines.
For
So
the audience, DOL is digital opinion leaders. So for background, we are tracking 5,000 verified oncologists on X, formerly known as Twitter, 5,000, and every one of their comments about a clinical trial, we manually or semi-manually index. We extract that sentiment or that commentary, and we link it to that clinical trial. You can see here Niagara, Peace 3, etc. These are clinical trials. So that link is created, and then Ankit's AI comes and extract the sentiment. And I want to say that no other vendors have a way of quantifying the sentiment of panel of oncologists on newly disclosed data.
That's true, Bruno. So here is an example of the Niagara trial, which total has like 100 plus tweets or posts on X. So what we did is, for this conference, took we indexed all those tweets, and one by one we use LLM to categorize whether it was the tweet sentiment is overall positive or neutral or negative and or practice changing. Now, the critical part was, since these tweets are more clinical data. This is more. It has the terms that are mentioned in these tweets. They are drugs, disease, staging, setting, numbers, which was very hard for the initial for the normal libraries that we have for such kind of task. But we used LLM, so we did some prompting to first make LLM understand around these drugs, the trial arms, diseases, and indications that it is corresponding to. Then we also gave the endpoints of that trial, and then finally how that particular tweet, is it talking about the overall result, or is it just, I mean, the KOL comments, sometimes they can be sarcastic. There can be the sarcasm around the conference or a trial design. So the task included both clinical data analysis as well as the reaction sentiment, and that's how we built, using prompt engineering, the best possible algorithm to derive the insights from those tweets and then finally give the tagging. Now this is done at the conference level, which is it's just this is right now for ESMO. We are seeing we have similar stuff around at the trial level. So here we have the Destiny Breast 03, which has 357 Twitter reactions, and first we index all the top influencers who have posted around those uh, around this trial, and then every tweet has been indexed with a particular category, whether it's positive and or practice changing, and so on. We The same use case was applied here, uh, detecting the results, detecting the overall sentiments, and then finally we built the overall graph, which particular DUL, how positive. We gave a quantitative figures around the sentiments they have, and then finally this graph was constructed. So this this entire sentiment, usually it's when we read tweets, these kind of analysis is done for maybe marketing, maybe for the product review. But in this case, there was a slight difference because this included clinical data. So that was the challenging part, and I think we did it gratefully.
Uh, I noticed one thing for this trial. So this is all of the commentary for this trial forever, right, in our database.
Yes.
Uh, and we also have actually whoever has been mentioned in these tweets. So usually the principal investigator or the author of the paper. So we have an idea of who is mentioned in the tweet. But if you go to the histogram, there's no red. There's no negative commentary for this trial. So everybody says either they have a neutral comment descripting but no expression of sentiment, or it's a positive sentiment And there's only one person, it seems, who talks about standard of care and talks about practice changing. Let's look at that tweet because it seems that it's a positive trial. Everybody agrees positive. Nobody's complaining about it, but only one person is saying this is going to change practice. So let's see what the tweet is.
So the tweet is by
Practice changing, right? She's just saying practice changing. Um, but it's odd that only one person would have said that. So perhaps she's a bit of an outlier and her opinion is not shared by other people. Because if you take a different trial, usually more people are saying practice changing if it is, or there's more, in some cases, there's more negatives as well.
So if we see the Niagara trial, we see a
Yes.
list of
Right.
people saying around this as a practice changing.
Now, show the histogram of that one as well. So we see the overall mix of.
So in
Oh,
this case,
it's
we
not.
don't have the
Okay.
histogram. Give me a second. We can have the histogram as well.
Yes. And of course, we have two views, right? We can either look at it for the conference, in which case we only look at the commentary about that disclosure, or we can look at the entirety of the trial. And in that case, of course, that includes previous discussions of previous data. So it's a bit of a broader picture. And we see one comment, negative, otherwise a good amount of positive commentary.
In this case, I would say it's a good amount of practice changing comment.
So it's clearly, I don't need to understand the trial, I would argue, as an external person to know that this trial is at the minimum practice informing and probably practice changing. Let's look at the negative. Of course, Dr. Vinay Prasad from UCSF, who's a fascinating person to follow, but he's always, very critical. And here, what is he saying? It's expensive, or he finds maybe a problem in the structure of pretty bad. The author have not explained. Okay, so there's some data missing. Dr. Prasad is pointing it out, and that's his job. So he has a very important job in the community that way. So we're getting toward the end of this short podcast, but I appreciate you explain how you build this with your colleagues, and I'm so impressed. I think it's clearly people should not do sentiment analysis anymore. It's for the machine. There's probably some weird philosophical sadness to say sentiment is for machines now, Ankit. Right? Humans, we can have sentiment, but we have to leave to the machine to analyze our sentiments. So that would be my my closing thoughts. Do you have any final words, final comments, and then we'll close the podcast for today.
So I would say this is one of the biggest use case that we have worked on. They are yet to come more, and for sure this is going to be like there can be many outliers in this. Still, we are proceeding with defining the quality of these outcomes.
So there is occasionally a misclassification, and therefore we need to QC, and we are QCing the result, in particular
Yes.
the negative comments, because they're rare, they're very meaningful, and after the readers will go directly to watch them. So, Ankit Kalucha, thank you very, very much for joining us
Thank you.
today on our podcast for LARVOL CLIN, and again, building in public. So we're sharing with all of you our successes, but also, I'm sure at times, our hesitations or even our failures. Building in public. Thank you very much, Ankit.
Thank you.